Hey there, my stupendous scholars. We're going to go through right now some problems that are about proofs, okay, dealing with parallel lines. So we're going to go and, do a couple more because proofs take practice, and I'll kind of work you through some of the thought process on these. And then we have one more problem where we're going to actually solve a problem with some numbers in it, just to kind of help you out a little bit more. All right. So this first one here, I'm gonna go use this picture here, and then I'm also gonna be writing down on our paper. So the question, they tell you that line A is parallel to line B, and that angle 1 is congruent to angle 2, okay? And then now we have to prove that lines L and M are gonna be parallel. So we have to look here, and we're gonna mark some things. So we see that A and B are parallel. So I'll go ahead and I'll mark those. So we know these are parallel. And then they're also telling us that angle 1 and angle 2 are congruent. So here's angle 1, coloring it purple, and then angle 2, I'm gonna color it purple. All right, now we have to find a way to relate. You see here, angle 1 is on line L, okay? And angle 2 is over here on line M. And so we have to use the relationship here between 1 and 2 somehow to relate L and M. But first, angle 1 is over here by itself on line L, and we're trying to prove that L and M are parallel, right? So we need to use some of the facts about, A and B being parallel, and then L and M, we'll get to those being parallel from there. So the first thing we can see here, we're going to use A and B being parallel. All right, so A and B being parallel. Well, guess what? I know angle 2, right, is also going to be congruent to angle 4. And how do I know that? Because angle 2 and angle 4 are alternate interior angles. And so think about it. Oh, look, if I can find out that angle 4 is congruent to angle 2, that would also tell me that angle 4 is going to be congruent to angle 1. And that gives me a relationship between line L and line M, because angle 1 is on line L and angle 4 is on line M. And we can see here that if you look at L and M on our transversal B here, like we ignore line A, 1 and 4, those are corresponding angles. And we know from the converse of the corresponding angles theorem that if you have two corresponding angles that are congruent, then that means that your lines are parallel. So that's kind of the thought process that we're going through here. So just let me make that note here. Angle 2 and angle 4, those are congruent, okay, because of alternate interior angles, because A and B are parallel. So since we know A and B are parallel, we know that 2 and 4 have to be congruent. So that's what I'm doing there. So we're going to start writing down our statements. Okay, so the first thing, you always have to start with what you're given. And well, what did they tell us? They told us that A is parallel to B, and angle 1 is congruent to angle 2. And what is our reason for that? Well, it was given. Okay, it was given to us. So that's step 1. Step 2. We had to take that information, and we saw that angle 2 was going to be congruent to angle 4. Okay, so angle 2 is congruent to angle 4. And why do we know that they're congruent? Because that's going to be because they're alternate interior angles. Okay, alternate interior angles. And then from there, we said, okay, I have to make a relationship between the angles over here on M and relate it to this angle over here on L. Well, 4 and 1, those are congruent, okay? But how did we know that they were congruent? Well, we said, so this is number 3, since we knew that 2 and 4 were congruent, we could then conclude that angle 1 and angle 4 are congruent. Now, how did we do that? This is going to be that transitive property. Okay, remember, since angle 1 is congruent to angle 2 and angle 2 is congruent to angle 4, we can then, just skip over angle 2 and say, oh, angle 1 is congruent to angle 4. All right, and we're doing the transitive property. Okay, now we're doing the transitive property because we're dealing with congruency. Okay, if you're dealing with actual like measurements, numbers, that's when you use substitution. So when you're dealing with congruent items, when you're using that congruent symbol, that's when you're going to use transitive. Okay, so transitive. And remember, we're having to use angle 2 as the bridge between angle 4 and angle 1. So now we've got that angle 1 and angle 4 are congruent. Well, guess what? Angle 1 and angle 4, that angle pair, that's corresponding angles. And since our corresponding angles on lines L and M, since those are congruent, we can then use the converse of the corresponding angles theorem to show that lines L and M are parallel. So our last statement, statement 4, L is parallel to M because of the converse of the corresponding angles theorem. Okay, so there we go. That's a simple proof that you might use to prove that two lines are parallel. All right, we're going to go over here to our next problem. Okay, here's our next problem. We're going to do another proof. Let me actually move the camera some for us. Working with a big budget here, guys. You'll have to bear with me. Alright, so here's our next paper we're going to use. We've got this picture, and we're going to actually use this picture to do two different proofs. The first one we're going to do is they've told us that line J is parallel to K, and we're going to prove that angle B is congruent to angle G. Alright, so this first proof, we're starting off knowing that J and K are in fact parallel. So we're going to be using those straightforward angle theorems, not the converse ones, okay? So we need to prove that angle B is congruent to angle G. So angle B is up here and angle G is down here. So we're going to have to make some relationships that are going to, help angle B and angle G like meet in the middle, if you will. All right? And the key thing for this proof is using vertical angles. All right? So our first thing we would see, and I'm going to talk you through the proof, and then we're going to write it down. So B is going to be congruent to C because those are vertical angles. Okay? So I've brought B and I've brought it here. The next thing I will do is I will see, okay, H, because that's my other angle I'm interested in. What is it congruent to? It's congruent to E. And why are those two congruent? Because again, they are vertical angles. Okay? Oh, I'm sorry. I did H, not G. I apologize. Let me back that up. G. Okay, G is going to be congruent to F. Okay, G with F. Put X's here. Okay. We don't want those. Okay, G is congruent to F. And now we can see H is congruent to E. But anyway, so now we've brought G to the inside there. Our next step is going to be to make a relationship between angle C and angle F. Well, why do I need to relate C and F? Because if I want to relate B and G, then I need to relate C and F. And because I know that J and K are parallel, I know for a fact that C and F are going to be congruent because those are alternate interior angles. And I know that they're congruent because I know that the lines are parallel. So now we're going to start writing our proof here. So, first step. We said that B was congruent to C because they're vertical angles. Okay? Sorry, I'm left-handed here, guys. So angle, well, first we're going to start off with J is parallel to K. J is parallel to K, and that one was given. Step 2 was that angle B was congruent to angle C because of vertical angles. All right. Step 3 was that G was congruent to F. And again, because of vertical angles. And then step 4, angle B is going to be congruent to angle G, all right, because, oh, hold on. Skipping over a step here. All right, so step 4 was that angle C was congruent to angle F because they are alternate interior angles. Okay, and then our last step, step 5, we can finally now say that angle B is congruent to angle G and what is the reason for that? Well, it's going to be the transitive property, because remember, B is congruent to C, all right, and G is congruent to F, and then we have the relationship that C was congruent to F. So basically, you can replace angle C with angle B, and you can replace angle F with angle G. So because of the transitive property, that's why they are congruent. Okay, so there's that one. Sorry for the mistake there. Okay, now let's go, we're going to go the other way. We're going to start off with the understanding that angle A is going to be congruent to angle H. And we're going to prove that line J is parallel to line K. So now we're going with information about the angles, and we're going backwards to show that those lines are actually parallel. Okay. All right. So now what we're seeing here, they're saying that A is congruent to H. So I'm going to go with the red because I already have that marked. So A is congruent to H. All right. There we go. So A is congruent to H. And now we're going to have to prove that J and K are parallel. Again, we're going to make the same kind of argument, okay? We're going to go from the outsides of our parallel lines. We're going to go to the interior so we can make some conclusions there. Alrighty, so first thing I'm going to start off with is that A is going to be congruent to D because they're vertical angles. Alright, so right away, A and D are congruent because they're vertical. And then over here, like we did in our last proof on accident, we said H and E. Those are congruent because, again, they are vertical angles. Alright? So we've related the outside angles to these inside ones here. And so now we're going to think, okay, look at this, E and D. Those are congruent, right? Because they're the same color. We're looking at the red angles only for this proof. So E and D are congruent because they're the same color. And what kind of angles are E and D? Well, they're alternate interior. And we have the inverse of the converse of the alternate interior angles theorem. So if we see two angles that are alternate interior angles and they are in fact congruent, as we've shown, then the lines that are forming them are parallel. So that's what we have. So we're going to write our proof now. So we're going to do the formal written part. Okay, so first we start off with our given. So angle A is congruent to angle H, and that is given. So A is congruent to H. So we'll do a mark here and a mark there. And then the next thing we did was we said A was congruent to D. So angle A is congruent to angle D, and that was because of vertical angles. And then our next statement was that angle H was congruent to angle E. And again, because of vertical angles. Okay. So that marked. And then now we said that angle D is congruent to angle E. Okay, and we can now say that angle D is congruent to angle E because of that transitive property. And then finally, we can say that J is parallel to K because of the converse of the alternate interior angles theorem. Okay, so J is parallel to K because of the converse of the alternate interior angles theorem. All right. So very good. So again, with proofs, you just kind of have to think, okay, what relationships do I have, you know, like on these ones when you're trying to prove lines parallel and, you know, trying to show that if you have parallel lines, certain angles are true. Look at those 4 theorems for each. Okay, for trying to prove things, it's going to be those converses, and you have to see, okay, how can I show that a pair of alternate interior angles are congruent? Or how can I show that a pair of same side interior angles are supplementary? How can I show a pair of corresponding angles are congruent? Okay, those are the kinds of things you have to think. Try to figure out how to show that, and then you can fill in the rest of the proof. And on the test, the proofs or anything like that is not going to be complicated. I just want to make sure you have a basic understanding. All right, and here's our last problem that we're going to go through. I know, it's taken a little bit, but here we are. Let me switch over my paper. All right. So we have this picture here, and we are trying to figure out what this angle is right there. So first thing I'm going to do is I'm going to point this angle out right here, this 54-degree angle. This guy is going to be also congruent right here because those are vertical angles. And then the next thing we want to look at is these parallel lines and this transversal. Okay, I'm going to ignore the other transversal for right now. I see the parallel lines cut by the transversal. I see this angle right here is going to be congruent to this one up here because these are alternate interior angles. So I know this is also 54. Okay, that one's also 54 there. So now what you're going to want to do is you're going to see the fact that I have the 54, the 80, and this angle right here. Those are all three going to equal 180 because they're making one straight line. Okay, and again, this is not the only way to approach this part, but I'm offering you one way to do it. Okay, so we have 80 plus the 54 plus our question mark equals 180. And then once we know this angle right here, it's going to be the same as our question mark because those two are vertical angles. So let's write it down on our paper. Okay, we said we knew that this one right here, move it so you can see it. Okay, this one's 54, and this one's 54. And these three have to add up to 180, so 80 plus 54 plus, we don't know, equals 180. Okay, 180 minus 80, well, we have 54 plus, we don't know, is 100. And then take away 54, so our question mark is going to be 46. And since this is 46, we know this up here is also 46. Okay guys, so that's a few more proofs and another example problem worked out for you guys. I hope it will help you for the test, and I wish you the best of luck. See you guys later.